Hello, everyone, and welcome to the School of Engineering information session. I would like to begin by acknowledging the traditional owners of the land on which we meet, and I pay my respects to elders past and present. My name is Salman Durrani, and I am the Associate Director Education for the School of Engineering. On behalf of the School of Engineering, I welcome you all to Engineering at ANU. This introduction session on engineering follows on from the College of Engineering and Computer Science session that we had yesterday, which some of you might have attended. Of course, you can find the link to all the O-Week activities on the KEX website. This is the plan for the session today. Through our speakers, you will get introductory information regarding our undergraduate degree program. And also you will get a taste of teaching and learning to come this semester. Before I pass on to our first speaker, let me mention some important housekeeping rules. So during the presentation, please keep your microphone off to minimize disruptions. You can post your questions at any time in the chat. We have time set aside at the end to answer all the questions. With that, I will now hand over to our first speaker, Professor Sean Zhu, who will talk to us about the engineering program. Let me stop share and ask Sean to screen share.
Okay, thanks, Salman. Let me start sharing. All right. So, can you see my screen share?
Yes, I can.
Okay, cool. Hello, everyone. Again, welcome to ANU Engineering Program. My name is Sean. I'm the Bachelor of Engineering Program Convener. And what I'm going to talk about in the next, say, 10 to 15 minutes would be to give you a quick overview of the main component of the engineering program of study that you're going to experience in the next, say, 4 or 5 years. And I'm going to also mention some of the extracurricular activities that you can take part in to enhance or enrich your experience at ANU. So this graph or table roughly shows you the 4 main components of the engineering degree program that across the 4 years of study if you are doing a single degree engineering, and this will be stretched to 5 years if you're doing a double degree, but the engineering component will be essentially the same. So you can see that starting from the left-hand side, we have one component that is called systems engineering. And this is the very unique component that ANU engineering is focused on. And it consists of a series of well-staged courses that across all the 4 years, so that it will give you extensive exposure and practice to the systems engineering approach. So what this approach enables you to do is to be able to tackle real life engineering problems that are often very complex and require efforts from multiple engineering disciplines to work together and provide a solution. So you will not only be able to understand how to identify the problem and provide the solution, you will also understand how the solution will impact your engineering system or the real life scenario over the entire life cycle of the solution. And indeed, later on, Fiona will talk about the first year Discovery Engineering course, which gives you a little bit of flavor into what the systems engineering approach is like. And the second component, as you can see here indicated, essentially in the first 2 years of your program, you will focus a lot on the engineering fundamentals. And these are the foundational mathematics, physics, computing courses, as well as the foundational knowledge in electronics and mechanics. So these together will give you a solid foundation to allow you later on to dive into one of the engineering specializations and also being able to understand other specializations in a broader term. So the third, you can see that the component would be in your third or fourth year and fourth year, you will actually choose your major, which we usually call major, but here I just mentioned as specialization, right? So you will have develop advanced understanding and knowledge into one engineering discipline. Now, the fourth component here is essentially a set of elective courses, which you can choose courses anywhere at ANU, right? It doesn't have to be engineering or computing or science course. It can be economics, can be language courses. But what I have seen commonly our existing engineering students do is they use these electives to complete a second engineering major. So this is highly possible. So at the end of their 4-year of degree program, they actually end up completing 2 majors instead of just 1 engineering major. Okay. Of course, this only applies if you are doing a single degree engineering. If you're doing double degrees, then these electives will already be, occupied by the other program or degree program of study that you're doing. So here, this is just the list of the 5 majors that we offer at ANU Engineering. You can see that it actually cut across a very broad range of engineering disciplines. I encourage you to actually, on your own time, look at each and every of these majors, go to the program and courses website, understand what these majors are about. The thing is that you don't really have to make a decision now, right? You don't have to decide which major to choose at the moment. What you can do is to take your first 2 years of study, understand engineering a bit more, perhaps talks to conveners and lecturers from some of these majors to understand what content or what are they included in these majors. So towards the end of your second year, then you have sufficient time and knowledge to make an informed decision on what engineering major you are going to do. Okay. The most important website, if I have to name one, is the program and courses website for the Bachelor of Engineering program. So here I'm just going to show you that website. So sorry, quickly switch to the website here. So this is essentially the landing page of the program and courses website for Bachelor of Engineering program. And I'm not going to go through all the information here, but I highly encourage you to read it, and especially to understand what is the formal requirement for your program of study under the study tab. I have seen a small number of students in the past who have not probably paid attention to this formal requirement. For example, some students have have done more than 60 units of 1000 series courses, because when they do electives, they just choose a lot of first year courses as their electives, which would violate this requirement. If this requirement is violated, then some of the first year courses they have done cannot really be counted towards the engineering program. So they have to do extra courses at 2000 level or 3000 level, 4000 level courses to sort of make up those units. So what I'm saying here is the formal rule is really important for you to understand and completely familiarize yourself with and follow it closely. And if you scroll down to the end of this website on this tab, you will see there is a table that shows you the recommended or the standard study pattern or study plan. So you can use this to like a baseline for you to plan your study over the 4 years. Of course, if you're doing double degree, you are not going to look at this website, but you're going to look at the corresponding website for your double degree option. You will also see a similar table there. Okay. So the other thing that in your first year you may have been thinking about is, for example, there are some choices of math course and computing courses, you don't really know which course to choose. If that's the case, go to the first year advice tab. I'm not going to show you all the content here, but there are some guideline and advice about which mathematics or which physics course or which computing course to choose that would be better or best suits your scenario. Okay, but if you have any questions regarding which courses to choose or how to fit all the courses within your study plan, feel free to contact me for a discussion. So that's essentially this web page, and just switching back to the slides. Okay, so those are all about coursework, right? And apart from the coursework, you also have, or there are also extracurricular activities that you can participate in. Here I listed 3 of them because our engineering students are commonly participated in 3 of these activities. The ANU Rocketry is essentially a students-led activity where students from all part of the campus, doesn't have to be only engineering, actually there are also non-engineering students, to come together, work in the team, design a rocket, implement it and actually build it. Then they take their product into a national competition where they launch the rocket with certain specified amount of payload to a target height. So this actually will be competed against, for example, other universities' product. And similarly, we also have the solar car activity. This is probably more of an engineering students cohort activity where, again, you will work in a students-led team to look at the existing solar car that we have, improve its design, and also take the end product to either a national or international competition, which is usually in the form of car race, where you take our ANU solar car, race it against a solar car from UNSW, from other university or organizations. Okay, and these are the opportunity where you can work in a team where you have senior students mentoring the junior students and sort of have that kind of valuable experience. The middle one, where we have this Humanitarian Engineering Design Summit, which I think Jeremy is going to talk about in detail. But in a nutshell, what it enables you to do is to work with local community, to listen to the people in the local community, understand the problem affecting their life, and come up with engineering solutions to improve the quality of life for the local community. It can be in Australia or can be overseas. So coming back to the coursework part, as I said, if you have any question regarding your course choice, how to fit it into your study plan, or if you have any special circumstances that prevent you from following the standard rules, feel free to contact me and anytime during your program of study, right? So we can discuss and find out a solution. If you have any question this week, you can, of course, ask at the end of this session because we have Q&A session, as well as attending one of my drop-in sessions. I have just checked the registration. I think the Wednesday's session is pretty packed. So I would encourage you, if you haven't registered but wants to come to one of the session, please choose the Thursday session. That's running from 4 p.m. to 5 p.m. Canberra time, right? You can find this session, I think, in a college website. If you go to the O-Week activity, you will find them. All right, so at the university level, there are a whole range of services and support that the university provides to students. So here I'm just going to mention some of them. It's at least good to be aware of what support that university is providing to us. The Academic Skill and Learning Center, they provide support and advice to students regarding their study methods, essay writing skills, as well as how to, for example, how to reference others' work or quote others' work in your own report, because you need to really know what are the rules here to avoid inappropriate use of others' work in your own study or your own work. They also actually offer English language workshops and conversation groups, which targets or provide helps to students who need a little bit of extra help with their English language skills. So these are the academic skills and learning centers services. And also we have counseling service, and for students who may have some personal circumstances that affecting their study or their life in general, and they want to have a safe environment to talk to an experienced counseling officer, this is the place, I think, to look for help and support. The other commonly used or commonly sort of seen service and support from the university is the access and inclusion. And this office actually provides formal support mechanism for students who may have circumstances that prevent them or affecting their ability to attend classroom activities or completing some assessment pieces. So, the students can contact them, and they will enable them for the students to talk to the lecturers and the course conveners to work out alternative arrangement for them to engage in the study or completing the assessment. Now, the scenario or circumstances doesn't have to just be, physical or mental health conditions, but it can also be, for example, if you have carers responsibility or you are elite athletes that you need to attend some of the national competition during the semester. So these are all can be accommodated and supported by the access and inclusion. All right, so feel free to talk to them if any of these circumstances applies to you. I think that's all from my part. I'll hand over to Salman.
Thank you, Sean. Let me just screen share. Okay. In my role as Associate Director Education for the School of Engineering, I look after the education offerings of the school. And today I'm going to use this opportunity to talk to you about your feedback and the important role that it plays in your teaching and learning experience. ANU is committed to excellence in teaching and learning and will regularly seek feedback from you guys about how the teaching and learning is going in the semester. So this feedback allows us to monitor how the teaching and learning is going. In this regard, there will be multiple avenues to provide feedback during the course of the coming semester. If you have any course-related feedback, you can, of course, provide it directly to your course convener or tutors. If you prefer not to do so, you can send your comments to the Keck Student Services team using this email address, or to ANUSA and PARSA, the undergraduate and postgraduate student associations. You can, of course, send any comments to me or to the College Associate Dean Education, Professor Natalie Lloyd. If you provide us any feedback, then we treat it confidentially. Also, at the formal end of the semester, you will be asked to participate in ANU Student Experience of Learning and Teaching surveys, and the comments that you provide help course conveners to improve future offerings of the course. We also have a very important mechanism in place for improving the teaching and learning during the semester, and this is where class representatives come in. So next week, when the teaching and learning commences, your course conveners will invite you to volunteer to serve as class representatives in your engineering courses. So class reps are basically the ears and voice of ANU students. You help collect the student feedback. And during the semester, I have 2 meetings with the class representatives for all engineering courses. And we do a health check on the courses, and take any action to fix any ongoing teaching and learning issues. So please consider volunteering as a class rep in your engineering courses. I'll finish off with some important contact information. If you have any course-related inquiries, your first point of contact should be the course convener, and you can find the information on programs and courses. If you have any administrative inquiries, your first point of contact should be the Keck Student Services. I've given the email address here. And as Sean said, if you have any program-specific or education-related inquiries, then you can contact the Bachelor of Engineering program convener, Sean, or the R&D program convener, Professor Daniel McDonald. With that, I'll now hand over to Dr. Jeremy Smith to talk about the humanitarian minor within our engineering program.
Thank you, Salman, and a quick welcome to everyone as well. As I say, my name's Jeremy Smith. I've been at the ANU in engineering for a long time. I actually studied at ANU in engineering, did a double degree in engineering and IT. So if there's anyone here doing that combination, I can certainly highlight that, and that was a real benefit to myself. Since I graduated, which was many years ago though, with a focus on systems engineering, I've become increasingly involved in what we call humanitarian engineering. So this has emerged in Australia, particularly in the last 5 or 6 years, and is really focused on how do we take all of our engineering knowledge, all of our engineering expertise, how we can design technology, how we can deploy technology, and make sure that's being used to kind of overcome human suffering in its shorter sense. And how do we use that technology to improve quality of life and human well-being for everybody, wherever they are. And you can look at any country, any community, and you'll always find people who might be marginalized, vulnerable, disadvantaged. And what we want to make sure is that our engineering and our technology is available to everyone to kind of improve that quality of life. So that kind of covers a range. So that means, you know, how are we thinking about engineering and technology for disaster response and preparedness? So thinking about cyclones, bushfires, floods. And we have work in our college looking at how we're using new drone technologies, new satellite technology to kind of help combat and fight bushfires in Australia, for example. Humanitarian engineering also then covers through to the long-term community development. So with a particular focus on the United Nations Sustainable Development Goals. So how are we making sure that everyone has access to water, to food, to healthcare, to education, to shelter? And sometimes those take longer. So how as engineers, how are we contributing into achieving those goals? So as Sean mentioned, here at the ANU, we've got a number of opportunities to be involved, both within your courses and also what we kind of call co-curricular activities. So we're very fortunate. We work with a lot of community-based partners, so often not-for-profits, non-government organisations or social enterprises. And there we're working with them in combination to kind of design, develop, monitor and evaluate, deploy a range of technologies. So there's a couple of examples here. So for example, in Laos and Timor-Leste, we're working with an organisation called Abundant Water, who make low-cost ceramic water filters. So these mix clay with used coffee grinds, shape them into a pot. We fire that, the clay, the coffee burns out, and then we go through to sinter the clay, and we're left with a really efficient microfilter that can filter out waterborne bacteria, basically made out of 2 waste products. So as engineers, we can understand the material science that sits behind that, but from a human impact point of view, it's providing access to clean drinking water and the health benefits that come from that. An example here in Australia, we've been working with organisations around healthcare and accessibility and disability. So using emerging technologies around 3D scanning, 3D printing and additive manufacturing to develop and design and manufacture very highly customized technologies for both children and adults. Everyone's body function, body size is slightly different. So these kind of highly customized tools allow us to very quickly and at lower cost come up with kind of specific tools. And here you've got an example of a splint, an orthesis that goes on a child's ankle that can then help their development and help straighten out their kind of ankle. but it allows that to be done very quickly as the child grows. So a lot of it is about this kind of creative use of technology to make sure we've got that kind of human impact from it. So there's a number of ways to be involved. As Sean mentioned, we have a number of partners. So as we speak, we've got students involved in immersive experiences with 3 partners: Engineers Without Borders Australia, and we've got some students involved with a virtual program working with a community in Vanuatu, looking at road construction and bridge construction, and also vertical gardens for food security. And so our students are engaging with community members over there virtually in this instance to help kind of come up with ideas about how they can kind of work in those areas and what might be some appropriate technologies. We've got students engaged with a group in India called Pollinate Energy, or Pollinate Group, who do low cost solar PV, so solar voltaic systems for basically providing kind of lighting for informal settlements in India. Traditionally, what's done is wood fire is used, or kerosene, which has both negative health impacts, but also has carbon emissions. And that usually impacts on women and children who are usually at home doing the cooking and the household chores. So how do we use small scale solar PV to replace that so that those people aren't burning kerosene and burning wood? And so again, they've got the health impacts that come from that. And then we have another set of students who are working with a third partner called Unbound, focused in Southeast Asia around Thailand, Vietnam, and Laos, coming up with ideas around how do we help achieve the Sustainable Development Goals, but very much in partnership, but looking around education, looking around healthcare, looking around economic development. So these have all been operating this year in a virtual environment. In previous years, we've been able to have those as actual travel experiences. So students might go and spend 2 weeks with that partner in Cambodia or in India or in Timor, and work alongside those community partners and kind of bringing their ideas together and working with students from other universities. So we've got those immersive experiences. They usually come along every summer and winter. So we usually fit those into the summer and winter sessions so that you can focus on it for a solid 2 to 3 week block. The other way of being involved, or another way of being involved, is through our systems engineering core courses that Sean mentioned. So from 2nd, 3rd and 4th year, you get to pick from a range of projects, and we usually have a humanitarian engineering project in there somewhere. If you really enjoy that and you want to take it further, we then do have a 4-course minor in humanitarian engineering. So this is really framed around how do you take your fundamentals, your systems engineering, and then your discipline major, whether it's in electronics and communications or renewable energy or environmental engineering, and learn how to apply those skills into these complex humanitarian and development contexts. So how are you working socially appropriately and culturally appropriate with local communities, whether they be in remote Indigenous Australia or whether they're in Timor-Leste or Papua New Guinea. So it really allows you to kind of take those technology and engineering that you're developing, but learn some of those kind of development humanitarian response skills. So you can see the courses here. So there's an introduction to development to understand that big picture. We have our engineering for humanitarian context course, which is where we usually incorporate those immersive experiences. So they allow you to start to directly engage with some community groups, either here or overseas. And then 2 further courses from a set of elective lists, one looking at a particular context, either that short-term disaster response or maybe international development or maybe domestic development. And then a multidisciplinary elective course. Working in these areas is very multidisciplinary. So not just around different types of engineering, civil, mechanical, electrical, aerospace, environmental, but then with policy, with social science, with environmental scientists. And so the course we're offering at the moment is we've got engineering students working alongside development studies students to bring the best of both of those and understand how do they work together to make sure that we're achieving those kind of human development outcomes that we're looking for. So this has been running for a couple of years now, and as they often can fit into those elective slots, but allow you to really take your major and your other engineering aspects and really broaden it out into these areas. If you've ever got any questions around any of the opportunities or our humanitarian engineering program or any of the projects, feel free to get in touch. My email is just jeremy.smith@anu.edu. My office is about there somewhere, as well in the engineering building. So always feel free to drop past. Any questions, let me know. Otherwise, best of luck with your studies, and certainly I hope your semester goes well.
Thanks, Jeremy. I'll stop share now and hand over to Fiona to talk about discovering engineering.
Thanks, Salman. So I'll just share my slides. Oops, I'm on the wrong one. There we go. So I'm going to be teaching you Discovering Engineering this year. So Discovering Engineering is the foundation course for engineering at ANU. And everyone who's doing an undergraduate degree in engineering will be taking it. So in this course, the focus is on discovering engineering by learning what engineering can include, by developing engineering skills, and by doing engineering. So we cover a range of examples of what engineering can do. So some of these are pictured here. They include some of the most ancient examples of engineering in the world, which are in Victoria, the Budj Bim eel traps. And it's actually a UNESCO World Heritage Site. And it's been called one of the finest examples of ancient aquaculture and hydraulic engineering. And then covering some of the things that Jeremy talked about, looking at different ways that we can use engineering to help improve the human experience everywhere in the world, all the way up to something like the Mars rover Curiosity, which was launched last year and is still collecting data for us. So in this course, we like to think that we're teaching three broad ranges of skills. We cover professional skills, which are absolutely critical to being an engineer, but are somehow less obvious as engineering skills. Things like creativity, ethics, communication, and teamwork. And then technical skills, which are what you would sort of traditionally think of as engineering skills, things like electronics and programming and circuits and a whole range of other things. But most importantly, I think, or my favorite bit of my favorite area of the course is really teaching you these design skills. So the skills associated with going through an engineering design process, which is really the foundation of what it means to be a systems engineer. So in doing engineering, we really just throw you in there. We give you a project bag containing a whole bunch, a project kit, sorry, containing a whole bunch of electronics, including an Arduino board. And we get you to design and build a rover, a little autonomous robot that can navigate through this maze. So these are not very good pictures of some rovers that were developed last year. And the reason that the pictures aren't very good, and not just because I'm not a great photographer, but also because we don't want to give too much away. We want you to come up with your own solution. But last year, we really had some fantastic examples of different rover designs that could navigate through this maze. So if at this point you're worrying that you're not going to be able to do this, this is where I tell you that that's okay. That's part of the experience of this course, is teaching you everything you need to know to be able to do that project. So this is actually some data that we collected last year from our engineering students from first year. And we asked them a bunch of questions about their level of experience in week one. So next week for you guys, and how much experience they'd had in a range of different technical skills and professional skills. And as you can see from the prevalence of the light pink here, most of them had little or no experience in all the things that they are going to need for the rover project. So if you're sitting there thinking that you've never heard of an Arduino board before in your life, don't worry, the chances are that most of the other people in the course will be in the same boat. And we have a range of learning activities throughout the course to help you gain the skills you need. So this is just a little screenshot of the timetable. So on a Monday and a Tuesday, we have 2 online lectures. You have to attend both, they're different. You can also watch these lectures afterwards, they will be recorded. However, I do suggest that you attend as often as possible if you can, because they're going to be active lectures. We're going to be doing some exercises. We're going to be getting some interaction. So I really would like as many of you there as possible. You also do one in-person workshop a week. So that's a 2-hour workshop. You can see that we currently have 7 options. Those may change as student numbers become more apparent, but you have to choose one of these, and sign up will open next week, so don't panic. In the workshops, we're going to be doing a range of things. Some of them will be used to do guided computer labs. So your tutor will take you through some online circuits and programming labs using Tinkercads. And then 3 times during the semester, we have these great fun hands-on workshops that I run, where we do a range of exercises and activities to help you build your rover robot. And then the rest of the workshops are opportunities for your rover project team to meet with your tutor and get one-on-one feedback and help with help with your project. So for all the remote students out there, welcome. Don't worry, everything that I've just said can be done remotely. We will be running special online workshops for remote students. You will be sent your rover project kit. So last year, we had them all packaged up and ready to go in week 2. And all you have to do is fill in the entry survey on the course Wattle page to tell us where you are and what your circumstances are. And we'll make sure that you have access to all the remote sessions and get you your rover kit. So the important thing to realize is that this is our 3rd year of uncertainty dealing with the pandemic and with remote learning. So we're actually getting pretty good at it now, and we've got this all under control. So don't worry if you are starting as a remote student. What to do next is to go onto the Wattle page as soon as possible, get familiar with the site, watch the welcome video if you want, but most importantly, fill in the entry survey. That's the critical part that gives us all the information we need to help you out as best we can. None of that information will ever be used against you. It will only be used to help support you through our course. So thank you very much. I'm really looking forward to next week getting started with you all. I'm Fiona Beck, your convener and lecturer. We also have the wonderful Jenny Simmons, who's our head tutor for the course. So from the teaching team, thank you very much, and we will see you soon.
Thanks, Fiona. Our last speaker for today is one of our current BE students, Chin Yang. Please share your screen and get started.
Thank you, Simon. Hi, everyone. My name is Chin Yang, and I'm in my final year doing Bachelor of Engineering and Science at ANU. And I'm majoring in Electronics and Communication Systems. I'm originally from China and moved to Australia when I was 15 years old. And I'm really keen to share about my experience studying at ANU. So my journey at ANU would be like many of you. So when I first came to Canberra as a student who just finished high school, I was pretty excited and a bit scared to start my new life here. And I spent most of my first year settling in ANU and get used to the difference between high school and unis. As we mentioned in the previous sections, I got a bit of taste in different areas in the engineering and studying all the fundamental courses in mechanics, electronics, and systems engineering. So I just want to share about some of my projects I did in my first year. So this is in the mechanics course, we used the balsa wood and design a bridge, and we compete with our cohort to find the strongest bridge we built. And this is the phone charger I designed and soldered myself in the electronics labs. And that's the rover our teams designed in the Discovering Engineering course. And I pretty like the delivery mode at AU because I've learned the theory in the lectures and tutorials and get a chance to apply this in the practical world. And so I did programming languages and force analysis, as you can see here. And I think I just be exposed to different environment and practice things I've learned in class. I developed skills in communication, leaderships, and teamwork throughout these projects. So you'll get a broad experience around engineering in your first year, and this will help you to build up your career in the future and help you to decide what major you want to do. And also another experience I want to share is about hybrid learning. And I know some of you are overseas or interstate because many of my friends couldn't come to Australia. And I know sometimes it's difficult to have the same experience if you are learning remotely and you might feel isolated. Also, I feel this is particularly hard for engineering students because we have a lot of practical works. But the good thing is we got the options for both of our remote and on-campus students, even though you might change the remote halfway throughout the semester. And all my courses are delivered via hybrid, which means there are options for us to complete it in person or online. And I remember last year when I did the engineering innovation course, we have a team member in China and others are in Canberra. This course is about working on a real world project with a client. And our team member in China is on Zoom with us all the time for all of our team meetings with the clients. And she took some tasks about research and sketching so she could complete it overseas. And at the end of the project, we went to the client's hospitals and did a testing on the prototype. And we record some videos for others who couldn't make it on the day, as well as the member in China. We end up with really good in that course. So there's always a way to get involved and be part of the cohort, regardless of where you are. So, and also in this semester, we are going back to on-campus teaching activities. And I'm really excited that I can be there. But if you cannot, also don't worry, because there is something for you to work out. Also, the other thing I want to talk about is the clubs and societies. I spend most of time in SAFO ANU program, which is on the top left corner. So this program is good for first year students or students who just starting at ANU. We pair the new students up with a later year students and do the peer-to-peer mentoring and help them settling into ANU. And the other three is I haven't participated in, but I know it's really good and some of my friends are in there as well. So one of them is Engineering Student Association. They offer a lot of networking and experience, also socially event. You can join their workshop to build up your skills in networking, also meet other people in engineering degrees. And the other one is solar car racing. As Sean already talked about, they build solar powered car and drive this in the remote area. I know they usually do race from Darwin to Adelaide within Australia, and that's a competition with all the other universities around Australia. And the last one is ANU Rocketry. They build rockets and launch this to 10,000 feet and 30,000 feet in a safe and accurate manner for the Australian universities rocketry competition. So these are really great opportunities to expand your extracurricular activities and build up your resumes and experience. So if you are interested in, definitely have a Google online and join them if you want. And there are also other clubs that are in the ANUSA web page. If you are interested, just have a go and look them up online. And that's all for me for today. Thank you. And I hope you enjoy your first year.